The headline screams that Google DeepMind has dismantled its Nobel-winning AlphaFold team after a massive strategy shift. For developers and data scientists, this sounds like a signal that AI research has hit a dead end or failed in production. But if you look at the engineering reality rather than the news cycle, nothing could be further from the truth. The narrative of killing talent is a misunderstanding of how mature AI systems actually work today. What we are witnessing is not an extinction event, but a necessary maturation, where isolated algorithmic breakthroughs are being absorbed into massive hardware infrastructures designed for scalable inference. When AlphaFold first captured global attention in early 2021, the industry was captivated by the promise of solving protein folding with unprecedented accuracy. The research paper itself had 9 authors and spanned 6 pages, yet its impact rippled far beyond academic journals. By February 2020, when the submission date arrived, a community began to form around the code that would change biological science forever. That repository has since accumulated over 14,800 stars on GitHub with nearly 3,000 forks from researchers worldwide. This massive engagement proves the team is not dead. They are simply operating under a different set of constraints than those who only saw the initial algorithmic novelty as the end goal. The shift we see today marks the transition from what used to be considered AI engineering in 2019, which was often about inventing new algorithms in isolation, to the modern standard where success depends on integrating those algorithms into systems that can serve millions of users without crashing. The AlphaFold team did not disappear. They evolved into the architects of the world's most critical inference pipelines. They moved from a specialized research group focused purely on model discovery to an integrated infrastructure model capable of managing complex hardware requirements at scale. This is why you see fewer isolated papers and more focus on deployment strategies, system design trade-offs, and the physical limits of the chips running these models. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the reality of running AlphaFold locally today versus 5 years ago. The constraints are no longer theoretical. They are hard engineering walls that every practitioner must face. To run inference for a single protein sequence now requires not just code execution, but access to modern NVIDIA GPUs or TPUs and up to 3 terabytes of SSD storage dedicated to genetic databases like UniRef90. This is a massive jump in resource intensity compared to the early days when researchers could run prototypes on standard laptops with modest memory footprints. The file size for version 1 was only 4,348 kilobytes, but that number tells you nothing about the infrastructure needed to actually use it now. This hardware reality creates friction points that define modern AI engineering careers. If you try to process a large protein sequence containing around 3,700 amino acids on standard consumer hardware, you will likely encounter specific failure modes that are not bugs in the code, but symptoms of scaling constraints. GitHub issue logs from users frequently show processes being killed with an exit code 8 during heavy inference tasks. In Linux systems, this signal does not mean a software bug. It means the operating system has enforced physical limits on memory to prevent total system instability because the application tried to demand more RAM than was physically available. These out-of-memory kills and 36-hour wall time limits are evidence that the field has moved past pure algorithmic tinkering into the realm of production-grade resource management. The team members who once focused solely on improving model accuracy have pivoted their expertise toward solving these system-level bottlenecks. They now design pipelines where CPU-bound data preparation, such as genetic and template searches, is strictly separated from GPU-dependent inference tasks. This architectural maturity ensures that even when individual jobs hit hardware limits, the broader infrastructure remains stable for other users. The model weights themselves are no longer just floating in open repositories. They are managed via secure storage with strict usage policies to control distribution and ensure compliance at scale. For developers wondering where their skills fit into this new landscape, the answer lies in mastering these system trade-offs rather than chasing the next algorithmic breakthrough on a leaderboard. The lone genius inventing new architectures is becoming less valuable compared to the engineer who can deploy those models reliably across heterogeneous hardware environments while managing memory constraints and data throughput. When companies consolidate AI talent into hardware-centric teams, as seen in this DeepMind restructuring, it signals that inference infrastructure has become more critical than the algorithmic novelty itself. This is not a sign of failure, but an inevitable maturation phase where operational excellence dictates adoption. The career pivot required here involves shifting your definition of value from inventing to integrating. You must understand how much RAM a model needs before it crashes, how to split jobs that exceed wall-time limits without losing data integrity, and how to manage the separation between data pipelines and compute tasks efficiently. The AlphaFold team members are still there, solving these exact problems you face today as they build the engine room where scalable AI lives. Their work ensures that when a researcher or developer submits a query for protein folding, it returns with accuracy without requiring them to understand the complex orchestration happening behind the scenes on massive GPU clusters. This is the new standard for engineering in the AI era. Success depends on managing hardware constraints at scale rather than just pushing model weights onto a server and hoping for the best. The narrative of dismantling talent is simply a misreading of how organizations adapt when their tools move from experimental prototypes to industrial-grade infrastructure that powers global scientific discovery. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.